Morning friends. Today I'm going to demonstrate you the VPNv4 using the segment routing in the core for the Nokia SR. So as you can see on the right hand corner, I am using the router R1, R2 and R3 as a core and C1 and C2 as a customer edge devices. R1, R2 and R3 are already running with the OSPF. So it has full neighborship with the R2 and learning all the routes, that is 10.100.100.2 is for R2, 10.100.100.3 is for R3. If we check on R2, R2 is having neighborship with R1 and R3, and it has reachability for R1, that is 10.100.100.1. 10.100.100.2 is for its own system IP address. 10.100.100.3 is for R3, and this is on R3. It has neighborship with R2 and exchanging all the routes with the R2. So basic connectivity is working fine. And if we check on the CE side, so BGP is up, but it is not exchanging those routes. Neighborship is not getting any route from the CE3 or from the VPRN. We will see why it is not exchanging those routes. But if we check the route table for VPRN 100, we should see some routes receiving from the CE side. So basic connectivity is working fine, and we just need to configure the segment routing in the core, and then for BGP and VPRN we need to resolve those routes using the segment routing OSPF. So let's see this configuration one by one. So the Nokia SR doesn't have the default sRGB range, but if you check the default global range, it says that static is assigned from 32 to 18431, and then dynamic range start from 18432 to 524287. And let's say if we start configuring the 16000 to 23999, which matches with the Cisco ISXR. So let's see what error we get here. MPLS label, router MPLS label, then SR label, start with 16000 and end with 23999. It says that label must start with the static label range plus 32. Because this range has already been assigned for static, that's the reason we are not able to assign this particular range to the dynamic one. So first we need to change this range, and it should be within the plus of the 32. So it should be divisible by 32. So last number which is divisible by 32 for the 16000 range is 15968. So first let's configure the static label range to 15968. And if we check the complete configuration, so we have configured the static label range 15968 and then SR label range. So now we should be able to commit this configuration. Yes. So now we need to replicate the same configuration on other nodes as well. Router MPLS label static label range 15968 and then SR label 16000 start 16000 and then end with 23999. This is the complete configuration and it's applied on R3, R2. Now let's configure the R3 router MPLS label static label range 15968 and then SR label 16000 start 16000 end 23999 and this is the complete configuration and we have committed. Now if we check the shoe router MPLS label range, then we should see that static range has been changed to 32 to 15999. So total available range is 15968, which we configured here, and then dynamic range is available from 16000 to 524287. So segment routing we are using 16000 to 23999. So this is how we configure the MPLS label range on Nokia devices using the model driven CLI, that is EMD CLI. Now we need to configure the index value and we need to advertise this index value into the OSPF. So if we talk about the OSPF configuration, router OSPF, so I'm running the instance 0, OSPF 0. So this is the existing configuration for OSPF. So I need to enable the segment routing, admin state. So first I need to enable the segment routing. Then I need to configure the prefix-sid range. So we have option here as a global, maximum index, and then start label. So global means whatever we have configured this one. So OSP will use the same range. But if you want to change the range, then this apart from this 16000 to 23999, apart from this range, if you want to configure separate range, you can configure for the OSPF that you can configure using the start label. But I am using the global, so let me configure the global here. That's it. And then area 0, interface system, node SID, index value 1. And then I need to advertise these entries into the OSPF. So advertising router capabilities. We have multiple options here. Link area AS. So I'm configuring the area. So this is the complete segment routing configuration for the OSPF where advertising router capability area, then segment routing, and then you can configure the prefix seed range. Here I am configuring the global. So whatever I have configured at the global level, I am going to use the same value here. So whatever I have configured here at the global level, so same value I am going to use for OSPF. But you have option to use the different as well. And then I am advertising the node seed index 1. Oh, node seed index 3. Sorry, it should be it should be 3. Interface system node seed index 3. Index value 3. Yeah, it should be node SID index 3 for R3. So now we should be able to commit this, and let's move to R2. Router OSPF0, advertising router capability, area, segment routing, admin state enable, segment routing, prefix-sid range, global, and then area 0, interface system, node SID index, it is 2 for R2. This is the complete configuration for OSPF. Advertising router capability area, segment routing, admin state enable, prefix-sid range, global, and then inside the system IP address, I'm advertising the index value 2 for R2. Now for R1, configure router OSPF0, advertising router capability area, segment routing, admin state enable, segment routing, prefix-sid range, global, then area 0, interface system, node SID index value 1 for R1. This is the complete configuration for the R1. Let's commit it. So once you commit the configuration, then OSPF will exchange all this information with their neighbors, and then router is going to figure out the label value based on the sRGB and index value. So if you can check the show router OSPF prefix-sid, OSPF, it should be 0 prefix-sid. So this is the value advertised by the routers. So for 10.100.100.1, this is the index value is 1. 10.100.100.2 index value is 2. 10.100.100.3 index value is 3. If we check the tool dump router segment routing tunnel, this is the same command. This is the similar command to show MPLS forwarding in the Cisco nodes. So here you should the in label and out label. So for 10.100.100.1, it is his own IP address. So you will not see here out label. So in label is 16001. For 10.100.100.2, router has calculated 16002 based on the segment sRGB and index value. This is in and out value is also same. For 10.100.100.3, in label is 16003 and out label is 16003. So if we can check the reachability, let's check OAM, LSP ping, SR OSPF, then prefix, let's say 10.100.100.3, and then provide the IGP instance that is 0. So we should be able to reach to the 3 using the segment routing, and then same for 2. So let's check the trace and let's check the label OAM LSP trace SR OSPF prefix 10.100.100.3/32, then IGP instance 0, to provide more detail output. So output format detail, so that it should show us the label value. So this is what the R1 pushing the 16003 label and sending packets toward R2, and R2 is doing the same. He is pushing the label 16003 and sending the packet towards the R3. If we check for the R2, so we should see the 16002 label value 16002 for R2. So it is confirmed that now segment routing is working perfectly inside the core. Now it is time for the BGP and VPRN configuration. Now you check BGP is running between R1 and R3, and if you check the show router BGP summary, so we should see that a router is exchanging the two route for VPNv4 on R1 and R2, R1 and R3, sorry, and VPRN 100 is configured for the services. So if we check that configuration, so admin state is enabled, customer is 100, autonomous system 65535, and this is the BGP VPNv4 related configuration where RD is 65535:1 and then root target, that is 65535:1. This is the BGP configuration towards the CE side. PRA 65500, local AS, local address, local AS number, and then export policy. If you want to export the VPN v4 routes towards the customer edge side, you need to have the export policy. By default, it is not allowed. But if routes coming from the customer edge, then it's automatically getting advertised into the VPN v4. But for the if you want to export those routes into the customer edge side, you need to have the export policy for that one. So we will see what is exactly that policy. And this is the neighbor, and this is the interface IP address. So this is the VPRN configuration. But if we check the route table for that, you will see the routes only received from the CE1, that is 192.168.11.11. This is the interface IP address, and this is received from the CE1. But we don't see the entries from the CE2. And if we check the BGP routes, VPNv4 routes, VPN IPv4, so we should see the two routes from the CE2, but those are not part of the routing table of 100 because we need to first resolve those routes via the segment routing. Then it will be part of the route table 100. So that's the reason if we check the route on CE1, you will see only the routes or the interfaces of C1. You don't see the routes received from the R1 because those routes are not available in the routing table because of the resolution. So let's configure the resolution filter inside the VPRN and inside the BGP. So first let's configure inside the VPRN. So we need to configure it under BGP MVPN. If we see here, we have the MPLS configuration here. So we need to configure it under MPLS, auto bind tunnel, resolution filter, auto bind tunnel, resolution filter, and then SR-OSPF. If we check this configuration, so this is the line we have added for the VPRN configuration, that is auto bind tunnel, resolution filter, and then resolution filter for SR-OSPF true. Same thing like a resolution filter we need to configure it on P3. So let's say service VPRN 100. So this is the configuration for VPRN and on R3. So let's check the policy configuration first. So this is the policy statement which you are using. So from protocol name BGP VPRN and to advertise the BGP towards the CE side and action is accept. So this is the policy we have applied on the BGP on the VPRN side. If you check that one, so this is the policy which we applied. So now we need to configure the resolution filter BGP IPv4 MPLS auto bind tunnel resolution filter SR-OSPF. This is the configuration we added here, auto bind tunnel resolution filter SR for the OSPF. Let's commit it. So now after committing that configuration, we can see the route has been installed into the VPRN table pointing toward the SR-OSPF. And then same status it should be there on the PR1 side. So on R1 we are seeing that 192.168.2.0, that is interface between R3 and CE2 pointing towards the SR-OSPF tunnel, and then 192.168.22.22 the routes which belongs to the loopback IP address of CE2 pointing towards the SR-OSPF. If we check the CE1 routes, so we got the route from the CE2, and if we try to trace 192.168.22.22 from source 192.168.11.11, so we should be able to see the CE1 is able to reach to the CE2. So main configuration for the segment routing to work is the MPLS label range. The main configuration for segment routing to work is first the MPLS label range values which you need to configure. There is no default value on this Nokia SR. Then you need to configure the advertising router capability area. Then you need to enable the segment routing and then configure the prefix-sid range and then configure the node seed index value for the node prefix-sid. And then for VPRN, you need to configure the auto bind tunnel resolution filter for pointing towards the SR OSPF. And that's it for today's section. And thank you very much for watching.